In this video, I want to talk about AI Observability. So you've shipped your AI product. Now, how do you know if things are going wrong? How do you know that it's improving over time? AI Observability is your answer. I'm Amber Lin from Brainforge, and I'm here to make you the leader who got AI right. Traditionally, before we had AI products, what we wanted to observe was the server up? Now, with AI products, there's more things we want to measure, such as, did the agent follow the right steps and call the right tools to complete its task? What was the overall token usage, cost, and of course, latency to its responses? What was the raw inputs and outputs the LLM used? Before we dive in, there are some terms I would like you to know, and I pulled in our AI expert, Arish, to help walk us through.
So observability is basically whatever code you have written, you want to profile the workflow that your code executes, and you also want to profile it across different dimensions, like how much time did that particular piece of code took, right? What was the input and the output which went to that particular portion of the code, right? So that is natively what we call as observability. So for an agent, it is, I think, most important that we know that what agent is doing internally so that we can audit it at a later point of time, right? So for example, if I have like, let's suppose an agent A, then what I would want from observability tooling is that, hey, what was the very first step that agent did? So maybe like it just like reads your README file or anything, right? It just reads your instruction or something. So this is the very first step which my agent took. And now I want to profile it across different things that, hey, what sort of time does this block take, right? So let's suppose if I say that, hey, this takes 10 seconds, then what is the next step that my agent did? So maybe it made an MCP call to a Notion server. So this is something which, let's suppose, took 2 seconds. So likewise, I think if you were to analyze this on a waterfall basis, I think you'd get what observability is trying to tell us, right? It basically points out how much time each block of code takes, and then what sequence of actions does the agent is following. Also, if there is any kind of error which we encountered, so maybe this is a successful call, and then there's also something like, let's suppose if it's trying to access Slack, but Slack is not accessible, so it's going to show us that this is an error block, right? So this is primarily what observability contributes to. Now, the individual action that the agent takes, right, that is known as observations, or you can call them as spans. So the entire journey is something which is called as trace. A trace is the entire journey of the request. So let's suppose a single request to a cursor agent is your entire trace. And then the atomic components or the atomic actions that your agent takes, that is called as spans. And this is like a fixed vocabulary for observability. So this does not change across different platforms like Langfuse or Braintrust, right? This is something which stays common. Okay, so this is how you would actually see all of the traces in any kind of observability software, right? For example, if I open Langfuse and then I go to home, and this is like an internal project that we maintain, right? Basically, this contains traces for all of the cursor, Claude, and Codex agents that everybody on our team is using locally. So, for example, if I open this Claude code, this entire thing is a trace. And now this contains the steps which that agent took, right? So if I click on trace, this is going to show me the input which I gave my Claude code, which is deploy brand rebrand to Railway. This is something which I asked my agent to do, and then is kind of the final output which my agent gave me, right? Internally, what tools did it access? Like, for example, I know that it accessed bash here, and what command did it run on bash, right? And I also know that this bash command actually succeeded, and then there is a time profile for this as well. How many generations did it take, right? So since this is agentic, we also need to capture that how many actual LLM calls are happening. So actual LLM calls are also getting logged here. So this is like the entire journey which is captured here. Apart from this, I think you would see normal details like the usage details, usage breakdown, how many input tokens went to the agent, and then how many output tokens did we consume, and then normal information like user ID, ENV, amount spent on that trace, right? So this also kind of helps us do an aggregate all of these traces. So I can create dashboards here. For example, I think we have dev usage dashboard, which kind of aggregates all of the total amount spent like in a single day or something. You can do that here. Now, this is something which is observability for AI agents specifically, because here, if you see that every step is agentic and it's capturing what are the LLM observations and what is the action that agent is performing. For vanilla implementations, right, you would do the same thing, but that is something where you would not have these details, right? The usage breakdown or something. So that is going to look traditional in the sense that we are only instrumenting the part of code that we want. So let's suppose if it's a single request to my database, and in between the database request, there's a backend server. So I would just maybe profile that, hey, what amount of time did my backend server take and then what amount of time my database took, right? So that is your
Mhm.
naive observability. On all of the integrations that Langfuse has is specifically aligned towards AI observability in sense that it captures your span records,
Mhm.
tool records, and then if you have like retrieval records and also I think that is also going to be captured here. So this is observability. And then what option we have in most of these AI tools is for evaluations, right? And evaluation run on top of your observations that which are specifically your LLM observations. So for example, if this is a
Mhm.
trace, which I'm seeing here, and these are the two LLM observations I have in this single trace, right? So now I have an option
Mhm.
to run different sorts of evaluators on top of these observations, right? So maybe if I want to check that, hey, this generation, I want to check that, let's suppose if this is deploy Brian rebrand to Railway, right? This should
Mhm.
actually, the agent should actually respond with a call to MCP server to Railway here, whether that happened or not, right? I can do that
Mhm.
via two different ways, whether I can actually grep and check over this command whether a Railway MCP server has been called or not, right? Or I can just deploy an LLM as a judge agent to just judge that, hey, this is the input and this is the output. Do you think that the relevant action or the appropriate action which was required was taken here, right? That is something I can do
Mhm.
inside this environment.
Quick question to interfere. I think my understanding of evaluations versus observability, we're still at the phase of evaluations was like before you ship or deploy, you're kind of checking your different versions to see if they will still produce the new results, and kind of observability is running constant. I think what you're showing is that you'll then run evaluators on the observability. So technically, evaluations is also going on constantly, or is that understanding correct?
Yes, that is correct. So evaluator is something which you can use on top of observations. Now, how do you want to frame that is completely up to you. But evaluation in any observability tool is something which you can do upon observations or upon traces which are present in the
Mhm.
software.
Do you think all of the evaluation tools are just built on observability tools right now? Like, do any other vendors separate them? It doesn't seem like they do. Like, everything on the market just technically observability tools with eval features right now.
I think most of the new tools, they do come baked with evaluation feature.
So, is this statement correct that you can't run evals without observability? Like, is that too extreme
That
or
is
is
true.
that the case? Oh, okay.
That is true. Yes, that is how it is intended. You should not run evals without observability.
At a high level, what does it look like to implement these things?
So I think these are directly integrated to the code which you're writing, right? So let's suppose if I'm writing an agent, then I make sure that
Hmm.
the agent is instrumented. So there's some sort of patch that you can apply to your code, which is going to
Hmm.
send your data to these tools, right? Be it Langfuse, be
Hmm.
it Brain Trust, or be it any other thing. One good thing about the entire ecosystem is that there is a single protocol which you can follow for sending data from your code to any platform. So by that I mean that if I'm following a single protocol, it means that I can change the provider anytime I want. So for
Hmm.
example, if
Yeah.
I'm using a single protocol such as I defined, right, which is OpenTelemetry. If I'm using OpenTelemetry, then
Hmm.
what I can do is that I can just go and switch in my code that I don't want to send my traces now to
Oh.
Langfuse. I want this to be sent to Braintrust. And then that should be automatically compatible because all
Uh-huh.
of these tools are built on OTel compatibility. And that is a convention which I think it is very necessary for every
Ah.
observability tool to follow.
Yeah, that is
Yeah.
so cool. That is so cool. So based on what you said, it seems like currently in building agents and building AI tools, the practice is to plan in the observability and eval piece early on. So when you kind of create a spec, will you also plan like observability
observability or how that's set up, or do you usually put it in as an afterthought?
No, I think it should be observability first. Yeah, everything from now on should be observability first because you really want to start capturing your agent's actions from the very get-go. That is something which is like my opinion, but most of the industry standards I think follows that because instrumentation is not something which is like a very hard process to carry forward. This is something which is like very really easy to set up and then start that process.
So if somebody who's new wants to set up observability or evals in production, what has been the pitfalls that you've seen?
The first point of failure would be, I think, you need to decide the volume of the data you want to capture in your observability tool, right? Because it can get
Hmm.
overwhelmingly large. And then you also want to instrument only relevant pieces of information in your observability software. Otherwise, you're just capturing noise and then it would be hard for you to make sense out of that data which is already captured here, right? So it is very essential to
Hmm.
plan out what you're capturing. For example, I think here in tracing, if I open this trace, right, and I have like metadata here, conversation ID, generation ID, workspace, I'm using modules and the cursor version that I'm on, right?
Hmm.
Now it is very essential for me to capture relevant information here. I can easily bloat this with unnecessary information like what is the IP address of my Mac, which is sending that, which is not really relevant here, right? Or 10 other things,
Hmm.
right? If I do that, this then gets become basically becomes too messy for me to understand this data. So it also here, I think in a trace, if I'm capturing too many small things, right? So that would also make it
Hmm.
very difficult for me to read the trace. For example,
I see.
here also I think I am not really sure where that the why is it making three glob calls, but I think this makes sense. But you do get my point, right?
Yeah. So when you set it up, would you pick what you want to include?
Yes.
Oh, okay.
You explicitly pick what you want to include in your traces. That is something which you control.
Another question. Once you have all these traces, how do we implement, I guess, one, how do we extract learnings from them in an efficient way? And two, how do we reapply those learnings? Do we use any AI workflows in there, or is it mostly manual checking different traces and arriving to conclusions like through a human?
So two things, I think. One is that you can directly set up something inside any observability tool. So a lot of traditional tools like Grafana and all had monitors, so which kind of monitored the failure rate of your program, the failure rate for your
Mhm.
API routes or something, right? And we also have set something similar in our internal project. So for example, I've set up a monitor which basically sends a alert in my Slack channel whenever like the average latency for the Brainforge assistant that we use goes beyond a certain threshold. Right. So I've set up
Mhm.
a threshold that, hey, whenever average latency goes beyond 30 seconds, right, just send me an
Mhm.
alert warning to my channel. So this is
I see.
one way of setting this up that I am immediately informed that, hey, my system is down or something is non-performant in my production setup. The another way
Mhm.
to consume insights from the system is that you can create an automated sort of triaging agent on sort of on top of
Mhm.
these agents, which check for what is something which is taking time, right? What is something which you can compose as a skill and then reuse as a skill. What is like the least used skill? What is like the most used skill? I think that is something
Uh-huh.
which we also do. So I
So
think we
that's like self-learning, self-healing loop, kind of is
exactly.
the term.
Exactly. So self-healing, it can be self-healing in a way that, let's suppose if I'm capturing something in traces and then I have a cursor automation setup which goes overnight and looks at the traces and then it suggests that, hey,
Hmm.
this was the skill which was referenced last night, but it was not able to get the relevant output to the user. Or maybe that it took like n number of iterations and it could have been done in two iterations, right? That is the insight which my agent is going to come up with. The cursor
Hmm.
automation agent is going to come up with, and then it relays that information to me, and then an engineer can go and then deploy that change.
So then essentially the self-healing loop is not in these tools, but we take the traces that we send to these tools or the insight that we have and relay it through maybe another agent or another loop that we have created.
Yeah. So self-healing, it can also be self-healing. So there is something known as memory, right? So what you can do is
Hmm.
that you can ask your agent to look at these traces. I have hooked up Langfuse as an integration to Victor. So I will hook up Langfuse as an MCP server to Victor. And then Victor also kind of allows me to, set up automations or cron. Then I'll set up a automation saying that, hey, Victor, go and look at the Langfuse traces every day in the morning or at night, right? And then whatever you find out from those traces, right? Whatever learnings you find out from those traces, just write it to your memory. Once it's written to its memory, and then its memory is something which is referenced at every conversation, at every turn, right? So now it knows that what mistakes it has made in the past, right? And what mistakes it has to avoid in future. That is a way in which I think you can create a self-healing loop.
Very cool.
Mm.
Thank you so much for taking the time to
Yeah.
explain observability and evals to me. I think that was very, very helpful.
Here's a definition from Brain Trust that I really like. AI observability is the infrastructure and practices that let you see what your AI system did, measure whether it was good, and systematically improve it. I like that part. It connects tracing, evals, and iteration into a single workflow so that production behavior feeds directly into quality improvements. So you'll have tracing that tells you what exactly happened inside the request, evals that tells you if the result was good, which I will cover in another video, and then iteration, which lets you go from a bad trace to a better prompt scorer without switching between different systems. With this loop of trace, eval, and iterate, you can turn problems in production into recorded datasets, and then you can run experiments on those datasets and arrive at measured improvements on your product. Without this loop, your observability would just be an expensive logging system. Now, there's other things you can do with your observability traces, such as monitoring and alerting, and also self-healing and self-learning loops, which we will cover in another video. Here are some best practices we will recommend. First, implement observability from day one. It's easy to set up with OpenTelemetry, and you can always switch it between the different systems if you prefer one over the other. Next, you want to have observability before evals, because you can't really evaluate what you haven't recorded. And be aware of the common pitfalls. Record only what you need. Too much traces would drown you in information and make it harder and more costly to observe and evaluate your system. Before we end, here's what the AI Observability Landscape looks like. There are AI native tools, such as Langfuse that we demonstrated today, and also products like Arise and Braintrust. There's application performance monitoring tools, which are more like traditional tools that's integrated with the software and will help you look at costs and latency, errors, etc. There's also gateway and proxy tools, which will sit between your tool, which will sit in front of your model API and log traffic by changing the URL. And lastly, there are platform native tools, depending what product you use, that also offer observability and evaluations. Of course, most of them all use OpenTelemetry as their language, so you can switch between these tools very easily. And most of the observability tools also offer evaluations, which we will cover in another video. I'm Amber Lynn from Brainforge. Thank you for watching.